All right, good morning or good afternoon, everyone. Thanks for joining this Zoom meeting. This is titled as Advice for Students Interested in Conducting Research in Geoenvironmental Engineering. So my name is Krishna Reddy. I am a professor at University of Illinois at Chicago. So we have a very exciting meeting today. So hopefully, um, this will benefit all of you. As of this morning, we have about 252 students who registered. So I want to welcome you all. Thanks for all your interest in geoenvironmental engineering research, and thanks for joining this Zoom meeting. First of all, I hope everyone is continuing to stay safe, healthy, and happy. Hope we get out of this pandemic soon, and hope we can get back to normal days quickly. So as I mentioned, as of this morning, looked at it, there are 252 students and few faculty members registered for this Zoom meeting from different countries. So mostly India, Spain, Turkey, Brazil, Argentina, China. So this shows there is a tremendous interest from people from all over the world. So just want to mention what is the purpose of this meeting is. The whole goal of this meeting is to excite and encourage students and young faculty to pursue research to address wide range of persistent and emerging geoenvironmental engineering problems. Hopefully that is going to be clear, based on some of the presentations that you will hear today. And also, other objective is to create a geoenvironmental engineering network to exchange or discuss research ideas and share research results and publications. So, we would like to have, this exchange of information to happen, even after today's meeting. So if you joined, please fill up the Google form posted in the chat box. So, we need that information to be able to correspond in the future. And then, I'm hoping that we will be able to organize some, geoenvironmental research webinars, maybe a topic or something that a presenter can go in detail. So, um, we will be able to correspond, about that information if you provide your contact information in the Google form. The meeting agenda, how we're going to do this program today. Basically, we're going to have a brief presentation by the panelists. All the panelists are, well-known researchers in geoenvironmental engineering. So, because of the time limitations, we're going to have very brief presentations. So that's what I'm hoping, after today, in the future, we could have a more detailed presentations, webinars by, every presenter that we have here. So we want to interact with attendees. So we want to, know what type of questions that you have. So we will answer all the questions at the end, but I want you to type your questions in the chat box as the presentations take place. So if you have a question, that comes to your mind, just, don't hesitate, don't wait, just type it in the chat box. We will try to answer the question at the end of all the presentations. So depending upon the time availability, we may answer your question live, but in case if we don't get a chance to answer your question live, we will answer, and then correspond with you later. Okay. But every question that you, type it in the chat box will be answered either today or, sometime in the future. Okay. So just I want to give you, I want to start the presentations, just to give you an overview of what is geoenvironmental engineering from my perspective. Very quickly, geoenvironmental engineering challenges from my perspective. So I always show this graph, this shows the development versus impact. So on x-axis, you see human development index, and on y-axis, you see ecological footprint. So when you have, human development index, HDI is more than 0.8, it's a developed country. So if it is less than 0.8, it's a developing country. And as you see, US is right here. It's definitely well, developed country, and there are many other countries in the Europe, Canada. They're all, developed countries, and many other developing countries are here. So India is somewhere here. I think China is somewhere here. The problem is all this development came about by lot of ecological damage. As you see, US is well, it's a developed country, most developed country, but it has, caused a lot of ecological damage. So same thing with all the other developed countries. So, but the Earth has a certain capacity, right? I mean, you are exceeding the Earth's capacity. So the ideal situation would be to be in this sustainability quadrant. So you want to be developed country, but at the same time, you don't want to cause, ecological damage that, this planet cannot take. So there is a, lot of these developed countries are trying to do their best to bring, themselves into this sustainability quadrant with the new infrastructure that is being proposed, or, retrofitting the existing infrastructure. But there is a lot of, opportunities in, developing countries where, you could go, you don't have to follow the other countries, developed countries, but, you want to follow like a horizontal path, to get into the sustainability quadrant. So without causing the ecological damage. So, we didn't care, when we were developing the infrastructure in the past, we didn't care about depletion of natural resources. We didn't care about waste generation. We didn't care about pollution. We didn't care about greenhouse gas emissions, and we didn't care about sustainability. So, you know, these are the concerns that we have right now. In the US, a lot of these environmental issues are required to be considered due to the passing of regulations or environmental laws. In 1976, there is a US passed Resource Conservation and Recovery Act that required to address recycling as well as disposal of newly generated waste and the need for engineered containment facilities such as landfills. In 1980, Congress passed another law, Comprehensive Environmental Response, Compensation and Liability Act, CERCLA, or known as Superfund law, that required cleanup of contaminated sites. So geotechnical engineers, they have knowledge about earth materials and groundwater. So they started, getting involved more in design of containment facilities such as landfills, and then investigation, design, cleanup of contaminated sites. And then US EPA has developed regulations and technical guidance for design of containment systems and remediation of contaminated sites. So many geotechnical engineers contributed to these regulations and technical documents, and the geoenvironmental engineering has evolved ever since. So from my perspective, what is geoenvironmental engineering? It is, the design and application of engineering solutions for challenges related to, non-hazardous and hazardous waste management, characterization and mitigation of contaminated sites, and enhanced environmental sustainability and resiliency. So if you look at a high level, these are the challenges that are addressed in geoenvironmental engineering. But to address these problems, we need multidisciplinary solutions. So we need soil and rock mechanics background, hydrology and hydrogeology, geochemistry and biochemistry, contaminant transport and transformation, human and ecological health risk. So truly, this geoenvironmental engineering is a multidisciplinary technical approach. So if you are dealing with geoenvironmental engineering, environmental characterization, risk assessment, containment, remediation, waste management, sustainability, so you need geotechnical engineering, but you need, all the other multidisciplinary background to address these problems. So the geoenvironmental engineering is geotechnical engineering plus more. So the plus more is, what makes it a little bit challenging to work in this field. So for more information, I wrote an article some time ago. You can find that information about it, more information about this. So geoenvironmental engineering is essential for environmental protection and sustainability. So I want to make one thing clear. We use the term environmental geotechnics, And we use geoenvironmental engineering. Environmental geotechnics is application of traditional geotechnical engineering backgrounds such as settlement analysis, slope stability analysis, seepage analysis in addressing the geoenvironmental problems. However, geoenvironmental engineering is application of all relevant multidisciplinary knowledge to understand and develop engineered solution to the geoenvironmental problem. So looking at the problem holistically from different angles and coming up with the solution to this. So geoenvironmental engineering is much broader than environmental geotechnics. So I like using geoenvironmental engineering because we do more than geotechnical engineering in these things. Also, the way we write geoenvironmental engineering is like, people write it different ways. The right way to, write geoenvironmental engineering is the last one that I mentioned. So I try to tell people about, these things all the time. So a lot of people are now teaching geotechnical engineering courses, and also they started to teach geoenvironmental engineering classes. So a lot of the students in universities right now, they are getting exposed to geoenvironmental engineering. As I said, geotechnical engineering plus the additional background that you need. So therefore, we are addressing, with the classical geotechnical engineering courses, we are dealing with infrastructure development, and with the geoenvironmental engineering courses, we are addressing, sustainable environment. So I teach these geoenvironmental engineering classes. I use this textbook for 3 courses that I teach. So, there are resources to, teach the courses. So quickly, I want to say, what are the geoenvironmental engineering problems and challenges? So very quickly, there are a lot of challenges dealing with the municipal solid waste. This is there in every country. I mean, in US, we have engineered landfills, but in many countries like India, Brazil, and other places, we have dumps. We don't have engineered landfills. So we need to do the recycling. We need to do, waste containment. We need to do integrated waste management strategies. So geoenvironmental engineers play a major role in that one. So there are a lot of issues with hazardous waste. You have hazardous waste landfills also, but there are other things, recycling and other things that can be done in this. So nuclear waste is considered as a clean energy because it does not emit any greenhouse gases, but you know the containment of this kind of waste is very challenging, and you need to think about containment barriers for these things. So mine waste is a huge problem. You want to make sure that these containment systems are physically stable, as well as the contaminants are not allowed to spread. There are challenges at coal mine sites, even at coal power plant sites. You have a coal combustion residues. Management of those is a big issue. So there are a lot of geoenvironmental issues. Industrial byproducts, we generate a lot of these byproducts. So instead of wasting these as a resource, wasting these as a, disposing these as a waste, so there are a lot of opportunities to reuse these materials and conserve the natural resources. The polluted land, we still, developing countries have no regulations, and they are still disposing the waste indiscriminately. So you still continue to have these kind of problems. We need to address these things. And as you know, these days, you hear a lot about climate impacts, extreme events. That's all due to greenhouse gas emissions. And, controlling the greenhouse gas emissions is a geo-environmental issue. So, and also addressing resiliency, designing the geo-environmental systems or engineering systems in general, to be resilient is a hot topic these days. So in a broader context, we should be looking at sustainable development. Population growth is there, climate change is happening. So we need to address these issues related to greenhouse gases, pollution, waste, resource depletion, socioeconomic issues, sustainable development goals. So these triple bottom line aspects are now being considered in geoengineering or engineering in general. So there needs to be a lot of work that needs to be done in geoenvironmental engineering on these things. So just to recap, so we have a lot of issues with the waste management, industrial byproducts. How do we clean up, contaminated site? How do we mitigate the greenhouse gases, address resiliency? And how do we, take on this broader challenge of, resiliency? So even though it sounds like too much to handle, but this provides a lot of opportunities for researchers. So all the students out there, if you are looking for research problems, so this is, the great thing that could happen to you. So a lot of things are new, a lot of things are not studied very well, and this makes it, very interesting. So all of these, whatever we address in geoenvironmental engineering, they are towards achieving these global sustainable development goals. So it's very worthwhile to pursue this kind of research. So in my lab, we work on environmental remediation, waste management and landfills, life cycle assessment and sustainable and resilient engineering. And, we also do classical geotechnical engineering. So in our research, we do the bench scale testing, we do the large scale lab testing, we do the numerical modeling, and we do the field testing. So the whole idea is to understand the fundamentals and then develop the solutions that are practical to be used in real world. So here are some publications. You can know more about our research through these publications, and you have my contact information right here. So with this one, I want to thank you all for joining again, and then we'll go through the presentations by different panelists. Um, just I want to invite uh, Professor Jeff Evans um, to upload his presentation. And then meanwhile, let me just introduce him. Uh, one sec. Okay, Jeff, I don't see, yeah, that's good. So I'm glad that Professor Jeffrey Evans has joined this meeting. Uh, Dr. Jeffrey Evans is a Professor Emeritus of Civil and Environmental Engineering at Bucknell University. It's in Lewisburg, Pennsylvania. He received BS from Clarkson University, MS from Purdue University, PhD from Lehigh University, all degrees in civil engineering. Prior to joining Bucknell University, Professor Evans spent over 10 years as a consultant with Woodward Clyde Consultants. Now it's known as URS, AECOM. And he did so well that during that time, so he got the Young Professional of the Year award. He also served in the US Army Corps of Engineers Reserves as second lieutenant and first lieutenant and captain. Then he joined, after all that practical experience in industry, he joined the Bucknell University. And then, he was an excellent teacher and researcher. He received honors, such as class 56 lectureship, a presidential professor for his teaching and, contributions to the university. He visited UK multiple times. He was a visiting academic in Cambridge University, University of Nottingham. He was also senior scientific officer at Warren Spring Laboratory. He received overseas fellow at Cambridge University. So Professor Evans has authored and co-authored over 100 publications in the area of geotechnical and geoenvironmental engineering. He is professionally very active. He is a member of ASCE, Geoenvironmental Engineering Technical Committee. So as you will see from his presentation, he has contributed significantly to the geoenvironmental engineering field. So I welcome Professor Evans to present his perspectives. Jyoti, can you unmute him?
Here we go. Now you can hear me?
Yep.
And can you only see one slide at a time, or are you seeing my preview screen?
No, I can see only one side at a time.
Okay, excellent. So thank you all, and thank you for that kind introduction, and allow me to skip one slide. I think for all of the students, I'd like to say you're going to hear a perspective from each of us that is informed by our experience, and collectively, you should take to heart what works for you, and do what's best in your environment and for your expertise and your talents. And so one of the things that Krishna pointed out is I have a pretty diverse background, which is what I had on the first slide, which I will skip. That happens to, the picture happens to be my first slurry wall project in 1977. But while working, I had a lot of practical experience before the term geoenvironmental or environmental geotechnics came into use. As Krishna pointed out, 76 was RECRA, 1980 was Superfund. So we were doing slurry walls for groundwater control, municipal solid waste. We were putting soil bentonite liners under coal piles. We were building embankments out of fly ash, conducting various site investigations where we're trying to build on contaminated land. Worked on a whole variety of containment projects, including Love Canal, Lapari Landfill, which became the #1 Superfund site at one point, Hooker S area, a lot of stability. So this experience, in my opinion, this diversity, if you will, 3 different schools, different jobs, Army, et cetera. For me, it's been personally very helpful to inform my research. That is, as I was in the field, as I was in the office, it inspires research ideas. The longer you practice, the more you realize what we don't know. So it raises these unanswered questions. It leads to research with relevance. And I think that's an important point that Krishna is making. And I'd like to make that you should be trying to choose research projects that have some relevance to the context in which you're doing your research. It also is a cycle that feeds upon itself. That is, it leads to additional consulting if you happen to be an academic, which in turn leads to additional research ideas. So you'll notice in my presentation as we go, I'll say this up front, it's at a high level. I'm not going to go down and say you should do this subject in slurry walls, or this is going to be a high level, which I think will lead in well to our subsequent speakers. So my advice is learn from your experiences, whatever they may be. You shouldn't just be out there, thinking of it as a paycheck, but observing, thinking, learning from your experience, and learn from your environment, reading the paper. What's the political situation? What is the natural situation? What are the problems of significance in your environment? I did say to Krishna, I would do a little bit of the history of what I'll call environmental geotechnics. I'll take we could have a debate over terminology, because other people have actually usurped the term geoenvironmental to mean global things like climate change and deforestation. But at least historically, the term was environmental geotechnology and environmental geotechnics. So I'll just use them interchangeably in this presentation. But prior to 1978, actually the fundamentals of much of what we do are in place. Contaminant transport, people like Mitchell, Lamb, Whitman, Grimm, clay mineralogy, Van Olfen. There were lots of material out there in the literature and research on compaction, clay water systems, mineralogy. So the fundamentals were in place. But Superfund and RECRA led to an explosion of this research in the field that was then called hazardous waste management. And I'll throw in some names. This will have a US bias because these are, I didn't do any research. These are just names that popped in my head. But these were all new PhDs in the area of 78 to 85. Kerry Rowe, Ed Kavazanjian, Dave Daniel, Rudy Bonaparte, myself, Jeff Dunn. So this was an area that we were recognizing that needed research, and you could do your PhD in this area of environmental geotechnics. I'll show you the syllabus of the first environmental geotechnology class taught in the US, which I did at Lehigh in 1985. The first conference involved around this theme was 1986, organized by Professor Fang at Lehigh, very well attended. I was trying to find a list of attendees, but I'm in California and not in my home office, so couldn't do it. And the first actual conference organized by one of our entities, in this case, the International Society, wasn't until 1994. Here's the syllabus, and I thought it was interesting. Krishna had a slide of topics that he covers in his classes, and pretty much they're all on here, starting with some fundamental soil forces, clay water electrolyte system, clay mineralogy, then moving upscale a little bit to permeability, compatibility testing, and then moving to solutions like vertical barriers, clay liners, and geosynthetics, stability, case histories, field investigations. So it's interesting that spring of '85, the syllabus probably could be used today as a first course in environmental geotechnics. And hopefully Krishna will make all these PowerPoints available should students or others want them. So continuing on the history, from about 86 to 90, there was an explosion of research. A lot of new PhDs, people, names now that are very senior people, Craig Benson, Chuck Shackelford, Krishna Reddy, John Bowders, all earned their PhDs in this during this time frame. In parallel, as it turns out, the geosynthetics was just kicking off. In 1986, Bob Kerner founded the Geosynthetics Research Institute. And of course, there's considerable overlap in the area of geosynthetics as it applies to environmental problems. It wasn't until 1997 that the ASCE recognized the discipline to the level of renaming the journal to the Journal of Geotechnical and Geo-environmental. And it wasn't until 2004 that the first textbook came out, which Krishna showed the cover of in 2004. It wasn't until 2012 that the first person who was named a Terzaghi lecturer that you could truly say this person is environmental geotechnics, a geo-environmental engineer, and that was Dave Daniel. I mean, some of the other people who worked on some of the fundamentals, Jim Mitchell, T. William Lamb, of course, they were Terzaghi lectures prior to this, but the first geo-environmental Terzaghi lecturer was 2012. The UK didn't get around to having a journal of environmental geotechnics till 2014. So all this history leads me to tell you as students, the future is really yours to write. What are the domains that are going to be captured by geoenvironmental? What are the new research areas? What are the new developments? What are the new understandings in fundamental? They're all for you to decide and research and run with. Again, at a high level, I want to, again, aim this for the students. You are all in a profession. That is a profession that is something that requires specialized knowledge, long and intensive academic preparation. And the profession you've chosen is engineering, which is the application of natural science and mathematics to the properties of matters and sources of energy. And importantly, that are made useful to people. And so you can understand all the science and math you want, but if you can't understand how to make that information useful to people, then it really is for naught, and it really is not compliant with engineering. And to do that, you really need to have some understanding of the human condition, human thought, and the social structure in which humans operate, the social relationships, the laws. So humanities and social sciences are an important part of your education, and whether you get that in the university or by reading, you need to recognize that engineering is not just science and math. And I noticed many of the topics on Krishna's circular graph clearly required you to understand the social structure in which you're operating. And so with that, I'll summarize sort of what I believe based on my experience is that a broad academic preparation is best. Obviously, a solid grounding in the sciences, including geology, a solid grounding in civil engineering, meaning all disciplines. You don't skip structures or skip transportation because you're interested in the geo-environment. You need a solid background to be able to practice in this field. Obviously, mathematics, which includes statistics. Social sciences and humanities are important as well to fill out the understanding. I also believe that if you can do hands-on experimental work, that is helpful. Not everyone will be an experimentalist, but having some experience in experimental work is beneficial. If you can get as an undergraduate or certainly as a graduate, you'll get research experience, but also try to get some teaching experience. Try to see what it's like to be on the other side, to explain what you understand or what you think you understand, I'd suggest you find good mentors. They can be extremely helpful in your career and in your research. Solve problems that are important to society, solving problems that are irrelevant or impractical. We need to advance the fundamental science, but we also need to focus on problems of our culture, of our society. I've also found collaboration extremely helpful. Other academics, industry collaborators, government collaborators, two heads are always better than one. And then also I suggest that you recognize the possibility of adapting existing knowledge and technology. The whole bio-geo area, adapting microbes and their behavior to changing soil behavior is a recent example. An early example is Terzaghi. He was a mechanical engineer. He took heat flow and he adapted it to consolidation. And finally, think critically. And if you are not familiar with critical thinking, just Google it. You need to be thinking critically about your work. And finally, I will say, here's a picture of Oxford, and not Oxford, England, but rather Oxford, Argentina, as a shout out to our next speaker. And it always reminds me to think of the context in which I'm doing the work. What are the solutions that will apply in your area? And with that, I'll say thank you for your attention.
Okay. Now, Franco. All right, just let me introduce our next speaker. So Professor Franco Francisca. So Professor Franco Francisca is a full professor at the National University of Cordoba in Cordoba, Argentina. He received PhD in civil engineering from the same university, but he did some of his PhD work at Georgia Tech in Atlanta, USA. He was a postdoc at Georgia Tech for 2 years and worked with the Professor Carlos Santamarina. Can you share, Franco, your Jyoti? One second, let me see the issue is here. Jeff, can you press on me or Franco and make host in the participants? See in the participants and then just
I've already unshared my screen, and I think Jody has to do this.
Yeah. Now it's fine. Now who is host now? No, you are still host.
I am.
Yeah. So just click my name. Can you see in the participants?
Yeah, I'm clicked your name.
Yeah. Just say
make host. I say okay.
Make host. Yeah.
Wait a minute. How about now?
Yeah, that's good. That's good.
Okay.
Now. Okay, good. So we are all set. So yeah, so he received his PhD at Georgia Tech. I'm talking about Professor Franco Francisca, who is the next presenter. And then he spent a couple of years as a postdoc at Georgia Tech, working with Professor Carlo Santamarina. And he also, was a Fulbright invited professor at the University of Wisconsin at Madison. And he also spent time at Latin American Complutense School in 2008. Professor Francisca teaches graduate level classes such as advanced soil mechanics and geoenvironmental engineering. So he's the director of the Porous Media and Groundwater Research Group. He published extensively on various topics in geoenvironmental engineering. So, I have a pleasure of inviting Professor Franco Francisca to give his perspectives in this webinar meeting. Professor Francisco.
Thank you very much, Professor Reddy, thank you all. I'm going to talk about what is the geoenvironmental engineering field from the view of South America. So let me start with a few examples. What are we doing in our research group with this topic? One of the more significant problems that we have in South America is related with waste disposal, as just mentioned Professor Reddy. So we started working with soil clay liners and always thinking in using the local soils as construction material. But as time goes on, we started to think about how we can have a new construction material, for example, by incorporating waste byproducts in soils. And with that, we try to find the way of having a low cost and high performance liners. For example, we evaluate the potential benefit of incorporating basic oxygen furnace BOF slag on compacted clay liners. We have two different approaches in this research topic. One is more related to material science and is an experimental approach, and the other one is related with numerical modeling. For example, we add the BOF slag to local soils that have significant amount of volcanic glass, and with that, we promote different reactions that help us to increase the strength and the stiffness of the soil. And we can control that by means of pozzolanic reactions. But at the same time, the addition of BOF slag in the liner, in the compacted clay liner, helps to increase the pH of the material. And by doing that, we find a very low alternative, very low cost alternative to sequestrate or retain the heavy metals that are always present in leachate within the barrier. So either we may have a high concentration liquid on top of the liner, when the liquid passes through the barrier, the concentration of heavy metals after percolation is close to zero. And if we can do that, now we can control the breakthrough time or the percolation time of these contaminants through the liner, and it's a very easy way to have a low cost and high performance liners to retain heavy metals. Other research topic that we are working with is related to the hydraulic conductivity, but also by considering bioclouding effects. So we try to put all together several of the different fields that mentioned Professor Reddy, as for example, the mechanical field, hydraulic conductivity, the chemical behavior of the material, and also the effect of bacteria that may play a significant role for the geoenvironmental engineering field. So with that, we started with several questions. For example, can we control the material properties that we are interested in? With that, can we improve ion removals? What are the main mechanisms that are responsible for the emergent behavior, particle fluid interaction, and so on? And also, we are just starting working with the bioplugging effect in geotextiles and geomembranes. If we have, as the figure shows, a porous media, and we can control or favor the growing of bacteria inside the pores, now we can change the available volume ratio for liquid flow inside the pores. So this means that with the eyes of bacteria, we may control volume ratio. If we can do that, as most of you know, we may expect a control effect on hydraulic conductivity. This means that we can now think in engineering layers with high performance. Other important topic for us is the behavior of unstable soils. In Argentina, we have 600,000 kilometers squares of unstable soils. This is a loess soil. There are this type of soils all around the world. This soil collapses when it saturates, but we are interested in complex phenomena, including non-aqueous phase liquids. So we mix soil mechanics, multi-phase flow, and unsaturated soil behavior. So what can we learn from the interaction between neighbors and soil particles? We run experimental and numerical analysis in this topic, and the key point is to understand how behave the soils below storage tanks and pipelines that sometimes have leakage of hydrocarbons, and that affects soil behavior. And of course, also the infrastructure that is how changes the collapse behavior or the strain behavior of the soil when the flooding liquid is water as a reference, but nature as the main interest. Other important topics for us are related with energy and soil properties and how that impact on the geoenvironmental. So we are studying thermal properties of soils, geothermal energy. I see that this is very important today, and it gives new opportunities for the geoenvironmental energy field, because when we have, for example, energy pipes, we have interaction between the pipes, heat flow, and the soil that is surrounding the pipe. So this is a very interesting problem. And also we are dealing with the dielectric properties of contaminated soils. As a summary of what is important for us when selecting a research topic within the geoenvironmental engineering field, I would like to say that we always keep in mind the importance of finding solutions to real problems and society needs. This is a motivation for everyone in our research group, but it's fundamental for master students because most of master theses are related with applied research. The research topic should include non-conventional analysis. So even if we are studying unstable soils, we are not running conventional triaxial tests, conventional consolidation tests. We are just considering coupled effect, as I just mentioned. The research topics should be of interest for the international community. This is very important for PhD students. We have to produce knowledge in our research group, and this has to be good to be published in very well and recognized international journals. We have to impact the geoenvironmental field. This is the bottom line of all our work. And of course, it's very important to be dedicated and innovative. So I think that's all. Thank you very much for your attention.
Thank you so much, Franco. Can we go? I want to change the little bit of order, Kristin. So let Claudio go for, he has a class to teach. So Claudio, you can go ahead and share your screen. And so the next presenter, I'm just changing the order of presentations a little bit because Professor Claudio has to teach his class. So I'm glad to, invite our, Professor Claudio Cameselle as a panelist. He is an associate professor of chemical engineering at the University of Vigo, Spain. He was a visiting professor and Fulbright fellow at the University of Illinois at Chicago, USA. He has over 25 years of teaching and research experience in the fields of chemical engineering and environmental engineering. His research expertise includes environmental remediation, um, and engineering solutions for industrial effluents, waste, and recycled materials, especially using electrochemical and photochemical processes. And he also works on membrane separation and electrodialysis for the treatment and recovery of industrial effluents. And he applies the principles of sustainability in his research. So his research is actually, creating solutions to address the real problems. Professor Cameselle has published many papers in reputed journals. So I invite Professor Claudio to give his perspectives. Go ahead, Claudio. Can't hear you. I can't hear you, Claudio. You have to
Okay.
yeah,
And
go
now?
ahead. Yeah, I can hear you now.
Okay.
Share the screen.
And
I don't see the screen.
the screen. Okay.
Yeah. Okay, you can go to the first slide.
Okay. So is working now?
Yeah,
Okay. Thank
it's
you.
good.
Sorry for. So thank you for the presentation. First, where we are in the city of Vigo. Is a coastal city in Spain, very close to Portugal. This is a view of the city, and the campus is about 10-15 kilometers far from the city. This is the school where we are. Is the School of Industrial Engineering, and that school has in fact two buildings: the old school in the city center and another building in the campus. And all the teaching is shared between these two buildings with different degrees. I teach in the campus, and my subject is environmental technology, and our research is related with also with the with the subject I teach, So this is the infrastructure we have. This is the laboratory one. This is the second laboratory. No, this is not a good view. And we use very often the analysis center for basically analysis, and also for the designing of reactors and any other stuff we need for the research. Our research can be organized in mainly three groups. One is the management of wastes and effluents. The first line is the recovery of valuable material from wastes, and the second is the development of new technologies for the treatment of industrial effluents, with two ideas. The idea is to remove the contaminants and a safe disposal of the effluent, or just try to remove the contaminants and recycle the effluent back to the industrial process. The second is the control of the environmental pollution, basically on soils and wastewaters. We work in soil remediation, especially in electrokinetic and phytoremediation, and also the combination of the two technologies. And now we are working also with some companies in the quality control of the wastewaters, municipal waters or industrial waters, well, with different objectives. One of the recent projects was about the phosphorus control and the possibility of recovery. and everything in a context of sustainability. So we try to apply the principles of the sustainable engineering to select the best option in the design of the solutions we propose for the different problems. Now we are specifically working in 4 different projects. One is the photochemical and electrochemical development of a reactor for the treatment of industrial effluents, with the idea to remove the contaminants, some contaminants, especially organics, and be able to reuse the effluent to the industrial process. And then we combine with electrodialysis to continue removing those contaminants we were not able to destroy in the first step. So the second line is the electrodialysis for the removal of the excess of the contaminants, or concentrate the interesting compounds in the effluent so they can be recycled back in the industrial process. And the third and the fourth project are basically related. This project is about the control of the pandemic through the analysis of the effluents in the municipal treatment plant, the sewage treatment plants. So you can see here, well, you can see in this plot, in this figure, you can see the plants we are controlling. This is the city of Vigo, and we are controlling about 15 plants around our region. And this is the bars are the number of cases of infected people in a specific location, and this is the concentration of the genetic material of the virus in the wastewater. So the idea is to combine all that information to make a model and predict the evolution of the pandemic, if the risk, and also if we are going to have more infected people or they are going to decrease, whatever. We are working with other groups in this project, obviously, because we have no experience in the PCR analysis. And similarly, we are analyzing the phosphorus in the different plants, and the idea is to determine if it's possible to recover the phosphorus from the municipal water or the sludge, and at the same time develop strategies to reduce the discharge of phosphorus in the environment, because the limit here is very, very low, is below 2 ppms. Okay, and that is everything from my side. This is just a general overview of what we are doing here, combining our background, which is chemical engineering, with environmental solutions. Thank you for, and sorry for, because I have a tight schedule today.
Okay, that's good. Thank you so much, Claudio, for squeezing in your time for this meeting. So let's next move to Kristin. Sorry, Kristin. So can you upload your presentation? Can you share your presentation?
Okay.
So wait 1 second. Yeah.
All right, thank you.
Okay, so now just I have a great pleasure of introducing, Dr. Kristin Samplard. She's an assistant professor in the Civil and Environmental Engineering Department at the Villanova University. So it's located close to Philadelphia. She received her BS from Northeastern University, MS and PhD from Colorado State University, all in civil engineering. She has over 15 years of research and professional experience together on especially the topic of engineered systems to control flow and contaminant transport. So right now she has active research program on bentonite-based barriers for environmental containment. And also she works on green infrastructure to reduce pollution from stormwater runoff. She does a lot of field investigations and advanced lab testing. She received funding from agencies such as National Science Foundation, Department of Environmental Protection, and Pennsylvania Department of Transportation. She is very active professionally. She's a board member of United States Universities Council on Geotechnical Education and Research. And she also holds a leadership position in the ASCE Geo-environmental Engineering Technical Committee. Professor Sample published excellent research papers in reputed journals. So I invite Professor Sample to present her perspectives and give some advice to geo-environmental engineering research students. Thank you.
Thank you for the introduction. Can everybody hear me? I don't have my normal setup.
Yeah, I can hear you.
Okay, great. I'm not in my normal office setup, so the controls are a little bit different. But thank you for that wonderful introduction. And I have been at Villanova since 2015, and it's an absolute pleasure to be here today and talk to everybody who's considering what to do next for geoenvironmental research. And let's see if I can, there we go. So one of the topics that we were tasked with talking about on this panel is our observations of emerging research areas in geoenvironmental engineering, to give some inspiration for everybody thinking about theses and dissertations, or new faculty thinking about research areas. And so before I share a couple specific examples of things that I'm working and my group's working on, I just want to point out a few general characteristics that we typically associate with what we call emerging research areas. And so usually when we have emerging areas in research, these are novel, fast-growing areas that have true potential for impact, like Professor Reddy brought up and Professor Evans. Does it have impact? So when you are considering potential research topics, just take a second to ask these questions. You know, is it novel? Is there growth in this area? And what's the true impact on some of these global challenges? And also, these areas, as has already come up too, they're usually very multidisciplinary. And so coming up with effective solutions to these, you know, pressing, complex global challenges usually requires collaboration and convergence. So a true merging of ideas and working closely together with people in sometimes very widely different discipline areas. And I would also encourage you to broaden your view of what you consider geoenvironmental engineering and how you define those boundaries. Because if you try to stick with a very narrow definition of geoenvironmental engineering based on prior and traditional work and definitions, you're going to miss a lot of potential opportunities where having your geoenvironmental expertise really brings something new to the table. And I'm going to talk about one particular research area as one of those examples. So to give a few specific examples of what I consider emerging research areas and I'm working very closely with, I have the 4 photos on the right. I'm going to spend most of my time on this slide, so don't fret if we're sitting here for a long time. The top left picture is actually an SEM image of an enhanced bentonite. And it's actually a polymer enhanced bentonite, to be more specific. And you may know already that bentonites, particularly sodium bentonites, are very widely used as hydraulic barriers for waste containment systems because they have low hydraulic conductivity. Unfortunately, you may also know that when these sodium bentonites are exposed to waste leachates or other solutions with high ionic strength and multivalent cations, that can result in a reduction of the swelling ability of the bentonite and a substantial increase in the hydraulic conductivity, such that the bentonite that you're using for a barrier can no longer perform acceptably as a hydraulic barrier anymore. And so that chemical incompatibility issue is well known for bentonite. And it's been the motivation for a lot of recent development of bentonites that are amended with polymers and other organic molecules to improve their resilience to aggressive solutions. So there's a ton of interest in this area right now. I would say the research has really exploded on this forefront over the last couple of years. And these enhancements to bentonites they're not only being researched as methods to create sort of super sodium bentonites that are more resilient to chemical incompatibility, but they're also being researched as a means to allow for use of, say, calcium bentonites or lower swelling or lower quality clays that may be more readily available in many countries around the world than the sort of high quality sodium bentonite we've been trying to stick to. So there's also opportunity to use these amendments to improve other materials to make them suitable for barriers. So the current challenge, basically, here's the gap, here's the opportunity for research, is that although all of this research on enhanced bentonite and the commercial manufacturing has really gained momentum, it shows that they do offer improved performance. There's very little understanding of the underlying physical and chemical mechanisms. exactly how these materials work, that clay polymer interaction. There's just a lot of uncertainty there, and it's going to require collaboration with polymer material scientists and a wide range of disciplines to really understand how these materials work. And that has to be done before we can truly engineer the design of these materials or predict their long-term performance. So I think that's a area for a lot of opportunity right now if you're interested in enhanced bentonites as one of the potential research areas. The top right picture, this has actually come up a little bit before already about this coupled behavior of soil. So the THMC in this symbol that I just made up last night for a visual is thermal, hydraulic, mechanical, and chemical. And so this is representing the coupling of THMC processes and how each of these conditions affect each other and the properties of the soil and the performance of the system. So applications for understanding of coupled THMC processes are important, include, but are not limited to, geologic disposal of high-level radioactive waste, carbon sequestration, geothermal energy, really any geoenvironmental system subjected to changes in temperature, chemical conditions, saturation. So many of these applications that I'm talking about, where you would want to consider the coupled THMC behavior, are central to addressing the grand challenges of growing energy demand and protection of water in the environment. And they relate to a lot of the challenges that Professor Reddy brought up at the beginning with the introduction. And so the opportunity here for research is that although over the last 20 years, we have a lot of advancements in modeling and in theory of THMC behavior, experimental evidence is lagging far behind and the data that we need to really improve these models. So any sort of experimental or even field work of THMC behavior of soils that we can couple with these models would be an excellent area to pursue also. The bottom right picture is a picture of green stormwater infrastructure for stormwater control management. And so maybe many of you are familiar with rain gardens, right, which are a typical type of green stormwater infrastructure, a GSI. But GSI also includes, green roofs, bioswales, bioinfiltration systems, a whole menu of methods. And these systems are designed to capture and infiltrate stormwater runoff, typically through soil media. And in that process, filter and remove contaminants from the infiltrating stormwater. So based on that description I just gave, this is absolutely a geoenvironmental application, but it's very often up till now not been viewed in that light. There's been some great work. Actually, Professor Reddy has done some work in this area. Professor Patricia Culligan has a great talk on GSI and geoenvironmental, but usually when we're seeing this green infrastructure work, it's being presented at water resources conferences and environmental and low impact development conferences, and hardly ever and our geotechnical and geoenvironmental venues. And so this area of green stormwater infrastructure, it's an emerging area within itself, but it's also a huge opportunity for geoenvironmental engineers to become more involved and work closely with the other disciplines, because we have skill sets and expertise in this area. It's saturated and unsaturated flow and fate and transport of contaminants through soil. It's what we do. And the environmental issues associated with urban runoff are just going to become more of a problem as the world's population continues to increase in urban areas. I think around 2050, it's projected that 2/3 of the world's population is going to be in an urban environment. And these urbanized environments are taking permeable surfaces and making them impermeable. And now you've created more stormwater runoff that needs to be managed and treated so that it doesn't impact the quality of the receiving water bodies. So a lot of cities are looking towards green stormwater infrastructure right now as a means of climate change adaptation and to improve resilience. And so again, another huge opportunity to get involved in some emerging research and actually, represent geoenvironmental engineering and bring our skills to the table in this arena. And the bottom left picture, like one quick sentence on this, this is an example of beneficial reuse of waste materials. So this particular picture is from some work we're doing on using reclaimed asphalt pavement to be investigated for reuse in sustainable infrastructure applications. And that there's a lot of opportunity there as well, a lot of waste that we haven't had a chance to fully test and characterize. So this was the main thrust of what I wanted to talk about today, was to just bring some examples of ideas to excite you for your thesis and dissertation research. But I'll in like 1 minute, really quickly flip through a couple quick general tips that I hope might be useful to you just as a young researcher. So as I mentioned, keep that flexible and evolving definition of geoenvironmental engineering. Don't shut yourself off from a potential opportunity because, sorry, paper fell. It doesn't seem you geoenvironmental engineering enough. The green stormwater infrastructure example I gave is a perfect example of an opportunity that could be missed if you just didn't really think about the system and how it really is a geoenvironmental application. I mentioned coming up with solutions through convergent and collaborative research. So if you haven't heard the word convergent or convergence or convergent research before, maybe Google it. It's really important right now to the National Science Foundation and national academies of this, not just multidisciplinary. It's not just a project that involves multiple disciplines. It's the merging of ideas and the deep integration of these different disciplines to come up with innovative, groundbreaking solutions that would not be possible working within a single discipline. The top picture is just showing other ideas. Look for the gaps between the theory and modeling and the experimental data we have. A lot of times there's gaps between those two sides of researchers. So always look there for opportunities. The coupled processes is one that I brought up in that aspect. Professor Reddy already talked about, and actually some others, about the importance of tying together your lab work with the field work with the practice. So again, look for those gaps and those connections for ideas. And the final note I just want to make is that just because I don't think that we can hear it enough, and I wish I had heard it more as a young researcher too, is just because you got rejected, just because your experiment failed, your paper didn't get through, it wasn't wasted effort. We all fail a lot all the time. All you ever see are the accomplishments, but all these wonderful experienced researchers that are talking today, I guarantee that there are several times that they failed or been rejected from things before they were successful. And so don't ever feel like because your proposal, your paper was rejected, that it was wasted effort. You always ended up learning something in the process, and you need this sort of professional resilience in research, especially for emerging areas and creative ideas. And with that, any questions, comments, I'm more than happy to talk with you more, as is probably pretty much anybody on my current research team. And so please feel free to reach out to me. And that's it.
Yeah, thank you so much, Kristin. That's wonderful. Yeah, thank you so much. So you're one of the talented young faculty. So it's nice to hear from you. And so I wanted to bring that perspective to some of the young faculty and the PhD students out there. So let's move on to the next presentation. Professor Nilo, if you can share your presentation. See if you are unmuted or not. Let me see. Ask to unmute.
Okay.
Okay. All right. So we are lucky to have Professor Nilo Consoli. He is the head of graduate program in civil engineering and professor of civil engineering at Federal University of Rio Grande do Sul, UFRGS, in Porto Alegre, Brazil. Professor Consoli received his PhD in civil engineering at Concordia University in Canada. Then he was a visiting faculty at the University of Oxford, and then at the University of Western Australia. He received several awards, including Telford Prize from the Institution of Civil Engineers UK, and also the Telford Premium by the Institution of Civil Engineers UK. He has published extensively in very top journals on variety of topics, including the geoenvironmental engineering topics. He is professionally very, very active. He is associated editor or editorial member of many geotechnical and geoenvironmental engineering journals. The top journals like ASCE, Geotechnical and Geoenvironmental Engineering Journal, Canadian Geotechnical Journal. Even on geosynthetics, geotextiles and geomembranes, Geosynthetics International, Ground Improvement, all those top journals he's involved in it. He has done a lot of research on different topics, but in particular, he has done excellent research on creating sustainable geomaterials using various waste materials. So I have a pleasure of inviting Professor Consoli to give his perspectives.
Thank you very much, Krishna. As you said, I'm going to present some of the studies that we have developed at my university with my group on reuse, in this specific case, reuse of waste materials for in earthworks, let's say. Okay, attitudes such as the reuse of waste, the definition of alternative for the exploitation of natural resources, and the search for new ways to generate and save energy are attitudes that reduce impacts of earthworks on the environment. Besides of that, we are also looking at economical and also social viewpoints of the use of these wastes. Specifically, the research lines that we are carrying out at this moment at my university are the use of industrial, agricultural, domestic, and construction wastes in the improvement of geomaterials. And the final goal would be the development of new alternatives for earthwork solutions that minimize environmental impacts, are more economical, and maximize social welfare. Here, I just put a few papers that we have published in the area in the last 5 years in this specific area. I asked Professor Krishna Reddy to send to all the attendees in order they can follow some of the stuff that I'm gonna talk later on. Okay, as examples of researches on sustainability that we are doing, let me tell you first of all, we have a patent that we just got like a year ago or that, in the development of quick lime and also hydrated lime from eggshell. And this is blended with ground glass. Both are residues that might be sent to, are wastes in some way that are put in landfills. And putting these two together, we got a new binder, and I'm going to show you the possibility of this new binder. We have a paper that was just published now in 2020 on the Journal of Materials Engineering from ASC. And here, just to show and to have an idea, this is how it looks like, the quick lime that we have developed, and here the hydrated lime that we also have developed in this paper that we have shown how it is. We have also shown that this quick lime that we have developed, both quick lime and hydrated lime, are chemically more than 97% of calcium oxide. And if we look at the X-ray diffraction of both of them, we can see that we have the Portlandite in the hydrated lime and mainly calcium oxide, besides of a few other stuff that are developing in this case. Here we can show the importance of this lime, let's say, together with the ground glass, in order to get the improvement of unconfined compressive strength of these materials blended with a sand, a specific sand. And we can just show that, and also here the initial shear models, we can also show here that the material that we have developed, this specifically eggshell hydrated lime, has results that are much better than the limes that are produced commercially, for example. We also have developed a study here that still is not published. It has been submitted to Construction and Building Materials, is in the second revision. And we show that if we use this kind of lime produced from eggshell, for example, we have a good ecosystem quality reduction, let's say here, or the higher reduction in the impacts that we might have are located in this area for a life cycle analysis, due to the we are not going to have any quarrying of limestone, and so due to that we have this reduction. All this study we have done, we have carried out for 100, 150, 200, and even 250 kilometers away to show the difference that we can see in such a case. Here, there's a paper that was published on Journal of Geotechnical and Geoenvironmental Engineering now in 2018, showing that, for example, this is ground glass from bottles, let's say that would be disposed in a waste field. And if we just have grounded it, we have done some diffraction studies and showed that this is completely amorphous material. This is the way that shows when it's completely amorphous. And besides of that, from a long time ago, we have developed an index that we called porosity binder index. Then when you put, for example, any kind of binder, in this case, the binder that we are studying is this ground glass with lime, any kind of lime, even the eggshell lime or carbide lime, which is also a residue. We can have, and that's the position here, eta is porosity, BIV is the binder volumetric content, let's say. We can show that whatever that you choose to compact and having different dry unit weights, different ground or glass contents, and also different lime contents, you have a unique or nearly a unique curve here that correlates this index with unconfined compressive strength, also with, let me show you, also with initial shear modulus, and unconfined compressive strength, you can have a unique curve here. And finally, this index also controls what we could call the durability of this material. So indifferent of the way that you are going to mix with different dry unit weights, different glass contents, lime contents, or any other kind of binder that you might use, you have a unique curve here. And this curve, so in this way, just to have an idea, it shows that if you have one result, the curve shape is always the same. So you can have the whole result, which is interesting in order to reduce the amount of study that has to be carried out. Here is just also some diffractometry studies showing that after some time you have produced tobermorite, which is like the same thing that you produce if you have had like Portland cement. You have CSH in this case, which is tobermorite here after some time curing period. Here is a paper also that was published in the second semester of this year on Journal of Geotechnical and Environmental Engineering on the use of this same material to produce layers in the field. And in order to check it out if it was going to work in the field when we are going to make this, this kind of material, let's say, in real size. So we have produced a size like 45 centimeters diameter and 30 centimeters deep, and this 90 centimeters diameter and 30 centimeters deep. And we put some plates on the top of it. And then we have carried out like plate load tests in order to improve or to enlarge the strength of shallow footing that we are going to be put on the top of it. We have shown that we have different ways of failure mechanisms that are going to happen. See if you can see some of them, you are going not to have the failure of this stuff, and others due to tensile stresses you have. But the whole study is in this paper that is in here, that is already published. You can take a better look at it. We also have done some numerical analysis to show why it's going to fail and such and so in such cases. But all this study is in order to show that the material that we have produced, this new material that we have using some waste, reusing some wastes and so, is as good as if you are going to use like cement, Portland cement, which we know that it produces about 8 to 10% of the CO2 that's producing that is set to the environment. So using this kind of reusable material, you can reduce drastically the problems with the effects of climate change effects and so on. This is another problem where you also use some of these materials. This is a soil in Paraguay, in Chaco, which is the western part of Paraguay, in which when you have some dispersive, sulfate-rich dispersive soil over there, they usually like to treat with lime, and after less than 6 months, that's what you have there. So the base of the pavement is destroyed completely. So this was published in Canadian Geotechnical Journal also this year. And we have also carried out a way to show that if you do the same thing that they have done, but if you add just a small amount of ground glass together with the lime, you have something that is durable and have a large strength. So in introducing some kinds of residues, specifically one, if you know what you are doing chemically, and so you can improve the material, and that's not going to happen anymore, that kind of problems. This was published, as I said, it's 12 to 21 already, but it's already published. You can see on this sustainable binders stabilizing dispersed clays, specifically in this case. Here is a continuation of it, showing the durability effect through that, how it works, and so for this case. This is also something quite interesting, how that we have carried out some tests in the field with this material and also in the lab. And we have shown that this index that we have developed in this guy, in this case here, he works also for the field stuff. These are results for different time curing conditions, and we have done for a longer time condition in the field, and we have collected specimens, and it shows that it's actually the same function, just up to the others here due to the temperature that is higher than usual. Here is a study that we have published in 2016 on Journal of Clean Air Production, also doing some life cycle analysis here, showing that in that case, we can show through that index that you can get the same strength through two different ways. You can get a strength with a given amount of the binder and a given dry density, or you can change both and get the same number eta, CIV or LIV or whatever. And in this case, we have shown that this green one is the one that we have the same confined compressive strength of the material, but that the one that is in red here. The only difference is that in this case, we have used a small amount of lime and a larger density. And in this case here, a higher amount of lime and a smaller density. The density takes the compaction that you do, or the lime, how much you add. Regarding embodied energy and global warming, we can show that if it's one, the use of all these cases for 3% of lime and using some higher energy, if you do something with smaller energy but higher amount of lime, you get double the embodied energy and the global warming, which is, it shows that it's better in less way to compact more material than adding more binder, for example, in order to get the same results. Here we have shown a similar stuff. It also was published now in 2021 in Journal of Materials and Civil Engineering regarding the cost of it, how you can get smaller cost. And in this case, is in the same way. If it's cheaper compacting more than adding more binder, which is nice to see that from the environmental viewpoint and also from the economic viewpoint, you have the same way of solving the problem. It's better when you are going to use some kind of chemical stuff like a kind of binder in order to improve. It's better to compact more the soil than just adding more material. Here is a problem that we have here in Brazil in the last few years. We have had two dams that used to keep behind them well, in this case is iron tailings that they have failed and lots of people have died. Due to that, in 2019, the last one that has failed, like Brumadinho, it was forbidden in Brazil to build upstream dams. And besides of that, we have about 800 upstream dams already built that they have to be, their problem of keeping them as they are and not putting anymore, but guaranteeing that they are safe. That's one way that we are looking at it. Let me show you. This is a way that it's done. You have a dam here, then you dispose the material, then you build another one, dispose more material, build a third one, and go on. And what we have done is like, the idea that we are developing in this moment is like to do this deep soil mixing using these materials that we have, these cements, let's say, that we are developing here, in order to get it, let's say, with larger safety factors in such a case of things that are already built. From now on, is just to tell you that it's not allowed anymore to build such a stuff. But as I said, we have about 800 of them already existing. And finally, this is also a paper that was just published in Transportation Geotechnics, showing that we have plenty of other resources, as I said, in order to improve this, any kind of soil, like rice husk ash, as I showed you before, ground glass, or even bottom ash, and of course, fly ash and other stuff. And we show that in this case, this index versus the accumulated loss of mass in a normalized way, all of them, they get to a unique curve, which is shows in here. So as I said, strength, stiffness, even materials that you have swelling problems, and or in this case, you have durability stuff, you can improve them, and doing just a few tests, to tell you the truth, at minimum one, you can already have an idea or other blends, how they would work. Okay, thank you very much.
Thank you, Nilo. Thanks a lot for your presentation. So let's move to Yeliz. Can you share your presentation? So I want to introduce Professor Yeliz Yukselen Aksai. She's a full professor in the Geotechnical Engineering Division of the Department of Civil Engineering of Dokuz Eylul University in Izmir, Turkey. Prior to joining this university, she was a professor at Silal Bayar University in Turkey. She received BS, MS, and PhD from Dokuz Eylul University in Izmir, where she is a professor right now. She also got BS, MS, PhD, from the same university. So it looks like she likes the university very much. She was a visiting professor for 1 year at the University of Illinois at Chicago, USA. Her research expertise is environmental geotechniques, ground improvement, surface properties of clay minerals, and remediation of contaminated soils. Dr. Yukselen Aksai published many papers and book chapters, conference proceedings. She's received several awards, including the Best Paper Awards and also the FABID Foundation Outstanding Achievement Award. She's also a recipient of the Turkish National and Scientific Research Council Scholarship. So without further ado, I invite Professor Yukselen Aksai to give her perspectives. Can you show in the PowerPoint mode, show mode? Slideshow? Yeah, just let me see if you are muted. 1 second. 1 second. Yeah, 1 second. Okay, now go ahead.
Okay, thank you, Professor, for introduction and organizing this meeting also. I want to give some examples about my research experiences. It is a little bit specific, but I think graduate students will see what geo-environmental engineers deal with. So geoenvironmental engineering is a solution to environmental challenges for soil, groundwater, and surface water. So under this geoenvironmental engineering scientific disciplines, we can count geotechnical engineering, environmental engineering, engineering geology, geochemistry, soil science, and microbiology. Sorry. I am not going to other one. Okay. Yes, the scope is very wide. So we can count a lot of research subjects under this area. So some of them contaminant transport, remedial action, waste containment systems, risk assessments, waste management, etc. So yet later you can look this one. One of them from my research experiences is the remediation of contaminated soils. For example, subsurface contamination is a worldwide problem. Thus, there is a need for an efficient decontamination methodologies. These techniques require mobilization of contaminants transported to a treatment plant or zone and deliver nutrients, microorganisms, or destruction of chemicals to degrade the contaminant. One of them, I worked on the electrokinetic decontamination. This is one of the methods about the remediation of soils. So this is my lab setup. Setup was in the UIC lab. So about the electrokinetic decontamination and persulfate oxidation. And also field applications is very important because the bench scale studies, you can get some results, but application of these methodologies in the field is more complex. So we need more efficient technologies, and the importance electrokinetic decontamination or remediation of soils increases day by day because of the increasing population, increasing technologies. So we will have more contaminated sites in the future. So we need more efficient technologies. For that reason, we need more research on this area, I think. And another important problem about the landfills. So slope stability is another problem in the landfill. So there are a lot of slope stability problems around the world. And so we need regular containment systems in the landfills. So as a geoenvironmental engineers, we have to design efficient, economical landfills. So because municipal solid waste properties change. So you have to know the composition, aging factors, unit weight, temperature, saturation degree, and hydraulic conductivity parameters of the municipal solid waste in order to design effective, economic, and reliable landfills. And problem, extremely heterogeneous structure containing very different properties, materials, height, void ratios, and varying engineering parameters depending on the composition, age, location, and environmental conditions. And it changes from country to country, even from city to city. So you have to aware the composition and the engineering properties of these municipal solid wastes. For example, this is the examples. For example, you see dry unit weight change and optimum water content change. And as aging process, the properties change. So we need much more research on this area. Also, rehabilitation after the landfill area, when you want to close the landfill area, you have to rehabilitate, and we need more research on this. For example, for the coverage soil, we need much more research studies on this one. And geosynthetics, another emerging topic, I think, in the geoenvironmental area, because we use geosynthetics in many different areas. And for example, in the landfills or at the reinforced walls, we use geosynthetics. And for example, we use bentonites or we use montmorillonite minerals. So we have to know about the soil behavior or display soil behavior, for example, in the presence of different contaminants, in the presence of temperature, for example. So in order to improve the engineering properties of montmorillonite in the geosynthetics, for example, we need much more studies on this area. This is a photo from our laboratory. We are doing research on the hydraulic conductivity of geosynthetics in the presence of different contaminant liquids. This is photo from our lab. There are some emerging topics from my mind. For example, effects of best liquids on barrier material properties, containment strategies for emerging best forms, for example, nuclear waste and nano-waste, pharmaceutical waste, animal waste, contaminant transport through low permeability soil barriers, development and evaluation of novel contaminant barrier materials. Like this, there are a lot of research area under the geoenvironmental engineering scope. So at the end of my presentation, I want to announce about conference. This is Environmental Geotechnology, Recycle Waste and Sustainability Engineering Conference. We are going to organize this conference in our university, Dokuz University. It says 2021, but because of coronavirus, I think we will postpone one more time because it was in 2020, but the situation is not safe yet. For that reason, I think we are going to 2022. But still, you can check the website. You see here, egrwse2021.com. So you can get information. Still, we can accept abstracts. So if you need any question, please send an email to me and we can help you. And that's all. And I want to wish good luck at your future studies. Thank you.
Thanks, Yeliz. Let's move on to the last presentation by Professor Sarat Kumar Das. Can you share your presentation, Sarat? Okay. So let me also, I think, unmute you 1 second. All right. So I have a great pleasure in inviting Dr. Sarat Kumar Das to give his comments. He is a professor and head of the Civil Engineering Department at the Indian Institute of Technology, Indian Institute of Mines in Dhanbad, India. He received MTech and PhD from Indian Institute of Technology, Kanpur in India. He was a postdoctoral fellow at James Cook University in Queensland, Australia, under Endeavour Research Fellowship granted by the Government of Australia. His research interests are many, but he has contributed significantly to the industrial waste characterization to use as a geomaterial And he also has worked extensively on application of artificial intelligence for data analysis in geotechnics. He completed many research and consulting projects. Currently, he is working on 2 international collaborative projects, one with University of Illinois at Chicago, other one at the University of Manchester, UK. So his research has led to 1 patent and many, many publications in reputed journals. And he's on editorial board of some journals. He's also very professionally active in ISSN GE, IRC, IGS. He gave invited presentations at national and international conferences. He advised many successful MTech and PhD students. So without further ado, I invite Professor Sarat to give his perspectives on geoenvironmental engineering.
Thanks, Professor Reddy. Hello, everybody. So what I understand about this geoenvironmental engineering, so I'll start what I got the motivation. So as Professor Reddy was also saying that with the industrialization, also if you see the book on sustainability, everything started with the pollution started with the industrialization. So if you look at that, we go to mining to extract our minerals. So while I am mining, so I have got some minerals and some other things which we call it as mine overburden or tailings. It can be iron ore tailing or it could be coal mine overburden. And what the minerals I am getting, again, I am processing in an industry. So industry, I am getting products and some byproducts. So these industrial byproducts and this mine overburden or this, it could be the mine tailings, if we don't put it in a proper position, if we don't take care of it, so it creates problem to environment. Like here I am showing one Azca dam failure of this bauxite residue. So what we need to do? We need to do some amendments, treatments, and that is what I say that is the purview of the geoenvironmental engineering in my thing. So that what you can do, you can replace part of these natural resources. So this Mother Earth, so what is the idea is that I should extract whatever is required from that, usable to me, and ultimately I should not give the back Mother Earth the waste. Rather, I should give it back the Mother Earth something not hazardous or not detrimental to the environment or to the Mother Earth. So that is the motivation or for which I am working on this type of problem. So here I show you that where I stay, Dhanbad is called coal capital of India. So here in the side, if you see the coal mines, they are dumping that overburden, and very close to it, there is also thermal power plants, which is producing fly ash. So the idea was to that combine these two and prepare some material. And that material I am saying is self-compacting or a flowable fill, so that it can be used as a replacement for natural earth. On this, we are working with Professor Reddy in University of Chicago on a Government of India project. So, but as I said, what is the research part in it? So this, as I said, it's not that ordinary earth. So we have to think about its proper use and how to add the properties. As already we have discussed that geoenvironmental is a very broad topic. There it's not confined to only geotechnical engineering. So when I'm talking about self-compacting geomaterial, it is same as I like self-compacting concrete, but of low strength. So I need to go to that part and check all these things, flow, bleeding, and then also I need to measure this porosity. And I don't measure porosity in the other way. I measure with the ultrasonic pulse velocity. So this is what I said. I'm not going detail into it, but when I say I'm going for a particular use, there is always some research to be done, and that is the very broad aspect or the area that is geoenvironmental engineering. Then another problem which we faced, and most of the things I faced or we are facing nearby in the locality, that I am trying to present. Here it is called that thermal power plant residue of fly ash. Now we are trying to as a replacement of natural sand. But many a time it is creating problem. But think why? Because it's not the natural soil or natural sand as it is. We need to read its properties. In comparison to sand, you see the properties are the spherical particles. So you cannot never expect that what will be as a natural earth. Another problem, this problem started when the client came to us. They said that after they were doing with fly ash, reinforced earth, but as it dried off, it tilted. And that what I said, if you see these properties, if I'm keeping some fly ash sample after compactant outside the desiccator, that means no moisture, the strength reduces considerably. For all three fly ashes, if you see it is reduced considerably. That means it does not have a cohesion. It is just called apparent cohesion. If it is water is there, then only it has got some strength, otherwise not there. Whereas there are some fly ash called high calcium fly ash or classy fly ash as per the ASTM. So there, what you can see, you have got sufficient strength and it is almost very close to 20 MPa. So that way, when it is fly ash, now people are using as replacement, or that is called pozzolanic material. Only ASTM or class A for classy fly ash is not sufficient. You have to identify properly that whether it is acidic or basic. Like here it is further classified whether it is sialic or calcialic or ferricalcialic, and then only you can expect its pozzolanic properties, because now many times you are using it as a pozzolan. So you see some fly ash has got these pozzolanic properties, but others have very low. Like here I say very low, but another you say very high. So all it depends upon its chemical properties you need to analyze. So that's the interesting part of this geoenvironmental engineering. I am talking about another industrial waste called granulated blast furnace slag from a steel plant. Look at the properties of calcium, very high, 33.5 to 56.1 in average. So people take it, but if you add it and it just and go for it as like alternative to lime, it's not working. So that's why you have to need to study its mineralogy, and based on this also, when I'm talking about chemical composition, I can define it as whether it's a basicity, I mean acidic or basic. And when I'm talking about whether it will act as a pozzolanic material or as a cementitious material, all depends upon its hydraulic modulus. So this aspect needs to be studied. Then another waste I'm talking about called ferrochrome slag, because when this industrial belt, so many industries are there and we're trying to read it as an alternate natural material. So this was very interesting. When I go to the grain size, this grain size was similar to that of natural sand. So here I compared the mineralogy natural sand, India standard sand it's called. You see all it is quartzite. But when I'm talking about the sizes are same, but because geotechnical engineering does not differentiate the size passing from 4.75 mm and retained in 75 micron, it is sand. So look at this, there is a huge difference. And when I go for its metal individual properties, you see the varieties of shape is available there. So you never expect that. You can directly use it as an alternative to the river sand. So what is the way? So we did some research on finding out the particle properties and say its properties like elongation ratio, flakiness, porosity, and so on. What's the use? If you look at that, I want to use it as a mortar. I want to use it as a flowable concrete or flowable soil. It will not be same like sand. So it will need more water because of this particle size. So that requires that the research part in it to study all these properties. Another problem here, it is called bauxite residue or red mud. So these ASCA red mud failure, it's in 2010. Now it has more than 450 papers are published on this particular failure of that dike. because this is still considered as not fully explained industrial residue. So a small test we are doing, why it becomes so catastrophic? Because it traveled a very long distance. Was it still in a fluid state? So can we make it in a very slurry state that its effect will be not extending more distance? So that is some amendment. I saw you some picture that if I do some amendment, I can reduce at least the impact, the distance of its impact. And there in its study, what is the zeta potential? So at what particular pH, if I can maintain it, then obviously it will not be very hazardous to a great extent. So that another problem while visiting the site, I found also nearby there is no vegetation. They said if you are going for a bauxite residue, all that area is all waste. It cannot grow any vegetable. The problem, it's a pH value is more than 10.5. Even my student, when he started, he said, I am not able to work. I mean, I'm facing the difficulty. So that time, as a common sense, I said, can you put some earthworms? They can change it. All the earthworms died. So that is how I started, called some bacteria available, which can also survive a very high pH. And that is how I started with this bioremediation or biocementation. And with one of my students, I said, this volume, can you consider? Like we say, air has a volume, air void has a volume, but not weight. So similarly, can we take it as a 4-phase system with this bacteria has no volume, no weight, but it's an effect. So that is called as a 4-phase system, and that bacteria or bioremediation is now a new topic, and many times we are trying to use it. And also, the same one when I'm going for the valorization, I found it can be used as an alkali activated material. Now they are saying it as an alternate cementitious material, 3rd generation cementitious material. After Portland cement, Portland cement, Pozolani Portland cement, and now they are saying alkali activated cement or geopolymer. These industrial words are very much a very good candidate. And you will see, I tried with one of it. And what is the advantage I got? It's reducing the corrosion to a great extent. So that also needs research more on it, how to make something, good valuable material. And another problem, as I said, it is a mining area, coal mine area. So I found there is a lots of dust, and reason there were cracks, and when the vehicle is going, and there were cracks. So we try to simulate in the lab, put it in the wind tunnel to find out what's the effect. So can I reduce the crack? So if I put some layers, you see, if I don't put anything, if I go just put some, impression here, they are just connected by the cracks. So obviously it will be connected, and then after it will start with the wind blowing, it will go out. So I want to provide some layering like this, and this was also with some biopolymer. So now coming to finally, for the youngsters, after you do all these things, what you have to do? You have to publish, because there is a proverb since long, publish or perish. Now we are saying publish in high impact journals or perish. Now I have applied frequently high impact journals, and maybe, or you won't perish. So if you go for only high impact journals and frequent high impact journals, then you won't perish. So this is that you have to go for publish in high impact journals so that you don't perish. So here I'll suggest some of the youngsters, because as a reviewer I have found they just take any journals which is some information is available. Sometimes it is very much misleading. So you have to be very careful about these predator journals, they call it. So they are sometimes they take very small time, and within a very small effort, you'll be able to publish it. But as I said, if you don't publish in a good journal, also you perish. So that way you have to forget about the quantity. It's more about the quality. So always suggest you, while going for your research, find out a proper journal, and also try to publish a good quality journal so that other people can follow it, and it will be a good contribution to this geoenvironmental. Thank you very much.
Yeah, thank you so much, Professor Sarat. So that was nice. The last slide, publish or perish, I think. I know in the US, we don't have like strict requirement on publishing for PhD students, but I know in India, Brazil, and Turkey and everywhere, the students must publish, I know 3 or 4 journal papers before they come for defense. So there's a lot of pressure on students to publish and also
Yes,
research.
otherwise their thesis is not accepted as by the university to publish, I mean, submit.
Also, I think research funding agencies are also looking at that record. So
Yes,
that was this like a nice way to end the presentations. I know we already exceeded half an hour, so
Yes,
I expected this because we had really all the 8 presentations and So what I would do is I would go around with each panelist for final remarks. And there are some questions in the chat box. I don't think we have enough time. So we will answer those questions, in email. So let's go through, each panel member and say final remarks. And we have got a new young geoenvironmental engineer sitting on the laps of Kristin. So here we go. So cute, Kristin. So yeah, anybody, Jeff, you want to go? So let's go in the same order that presented. So just a final remarks. I always say this set up like this. Okay, Jeff.
Okay. No, I have nothing more to say. It was great list of presentations. And I think that it went from the broad to the specific with good advice. And you can see each of the researchers, I think for the students to see each of the researchers focus on their strengths. And that's what should be doing. When I have young faculty ask, what should I be working on? My answer always is, what do you want to be working on? Do what you want to do. Enjoy what you're doing. And if that doesn't fit into your context where you are, then maybe you're at the wrong university or at the wrong place. So I think you could see that the passion for the research in all the presentations. And I know I appreciated it. And I hope the students did as well.
Okay, thank you so much, Jeff. So Franco, let's see. Some final remarks.
Okay. Yes. Thank you, everyone. I think that we all learned a lot from the presentations. As I always say to my students, I think that it's important to take in account what you want to do in the next years, in the next 3 years, the next 5 years, and so on. So it's very important to have a plan for the future, and that I think that starts with the proper topic, or choosing the proper topic for your thesis. Of course, as some of you mentioned, a good mentor and advisor. And I think that with all that, but dedication and enjoying what we are doing, all of you are going to success. So that's it. Thank you.
Thank you, Franco. Kristin?
Hey, it was so great to be here and hear from everybody and get to talk to all of you virtually. I guess final remarks similar to what Professor Evans said already. Make sure you're passionate about what you're doing. And even if you can't pick the project you're working on, find parts of that project that you are deeply interested in and really excite you. Build your team, I would say, as far as your peers, your fellow grad students, your mentor, other faculty, having a supportive team that will help you brainstorm and that you can be comfortable enough to throw crazy ideas out there with. Like, that's how we get through and we do things. And also to be there, when you do get criticism on your project, to help you kind of work through those comments and move forward. So build your team and be brave, right? I mean, I think sometimes, especially geotechnical engineering, we get made fun of a little bit for moving at a snail's pace in our advancements sometimes. And I think if we just be brave and we go out there and we reach out to people and try to be as transdisciplinary as we can, that we can do a lot. So don't be afraid to fail, and utilize your team.
Thanks, Kristin. So Nilo?
Well, there in the last slide that I showed, there was a saying that say that knowledge, let it flower. It can shape and will shape your future. So if you agreeing with mostly all of them, all of my colleagues that just have spoken, if you like what you do, that's all. You don't need anything else. That's it. Thanks.
Thank you. So, Yeliz?
First of all, for the research studies, we have to define the problem. So the most important part, I think, this one. So you should very accurately define the problem and try to solve this problem in the geoenvironmental engineering. It was great to be here. Thank you again for the organizing this meeting. Thank you.
Thank you. Professor Sarat.
Yes, actually, that's everybody has said about that passion. That's very important. So unless it matches, it's very difficult to proceed with your research. And the mentor is also important. And selecting a subject, and finding out the research component, it is more important. So that what I will say, while selecting the subject, it may be, that what I will say, what you do is not important, but how you do it is important. So that's what is important. So that's why you have to frame your research program properly. That so that any, the problem you consider of the society, you can think it of as a research problem. That's my answer.
Okay, thank you so much for all the panelists for taking time. Just to end the meeting, I just want to mention that the geoenvironmental engineering offers unlimited opportunities. Whatever you want to pursue, I'm sure there is a way to, include in the geoenvironmental engineering field. And I just, as the panelists presented, we need to be looking at real world problems. So try to solve real world problems through fundamentals. And somebody also said that think beyond the conventional. So just don't think the same way that other people have done it. What is conventional practices? This is the way we test it. This is the way we analyze it. But challenge them and try to go beyond the conventional. Expand the knowledge. Just doing something and publishing, is one thing. But are you creating the new knowledge? I think that's the most important thing that you want to ask yourself. Are you contributing something new that nobody has done it? And also, I was told in the presentations that you have to be flexible and you need to be evolving. So you just try to, as I said, geoenvironmental engineering is so broad area. If you need to learn microbiology, you have to learn. So you should be open to learning new stuff. And also, because this is a very broad field, the other keywords that came up are convergent and collaborate. So don't hesitate to talk to, other professors in the same department or other professors in other departments or other universities or internationally. I think this kind of a networking hopefully create, new opportunities, new connections to, ask questions and seek some help, and the last one I want to end with is professional resiliency. So I think, that's the important takeaway. Don't hesitate to fail. So try it, and if it doesn't work, I always say that failure is actually a great contribution. You are showing that something does not work. So you don't have to hide stuff that didn't work. You can be, you can explain that one, that you tried to do this one and then it didn't work. So nobody else will try to do the same thing and find the same conclusion. So so highlighting the failures are very important. I think the failures are the stepping stones to success. So if you have failures, then they eventually lead to the success. So with that one, I want to thank all the participants, all the panelists, first of all, for finding their time, spending time and effort. in preparing the presentations and making the fantastic presentations. I also want to, thank all the participants. I know, this Zoom organization for this meeting is a little bit tricky, but I hope overall it worked out very fine. So thank you very much. And I think, we have questions in the session, in the chat box, but we already exceeded so much time. I will, put those things in the email and copy everyone on this list. Okay. Thank you so much, everyone. Bye, everyone.
Bye-bye.
Jyoti, you have option to stop the recording?